टॉप पे रहे बाद में बात करें।
Okay, so I want to introduce about our next resource person, Dr. Syed Sanawajuddin. Dr. Syed Sanawajuddin did his BA in EC in the year 2008 from VTU, Karnataka. He then did his PhD from IIT Guwahati in the year 2016. His PhD thesis focused primarily on Chilean speech recognition. He has been working as a assistant professor in the Department of EC NIT Patna since January 2020. His areas of interest are speech processing, children's speech recognition, children speak verification. Over to you, sir. Please welcome.
So, hello and welcome. My name is Shahnawazuddin, but people call me Sayyid. I don't know why. Everywhere. Huh? Yeah, when I was in BTech, they used to call me Nawaz because Shahnawaz was a bit longer, took more bits and more bytes. So then they switched off to Sayyid in my PhD days. Again, it was shorter. So switching to Sayyid was easier. Thanks to my guide who promoted that name. And even now I am called Sayyid everywhere. Yeah, I'll be needing this. मुझे पीपीटी बनाने में बहुत उलझन महसूस होती है, so I prefer marker please. Fine. So let's focus here. Okay, it should be an interactive session. Please talk to me, stop me wherever you feel like. So Ankita is my PhD scholar. Yeah. So let's make it very interactive. You ask me, stop me, ask me every question. Before you leave, you should be knowing a lot of machine learning today. Okay. So let's first define what is machine learning. What idea do you have about machine learning? What do you know about machine learning? Nothing. Okay, machine learning is an automatic programming technique where machine writes a program on top of the data which does whatever is required to be done. Nothing else. You don't write a program. Machine writes a program. Now it's not a C program or a Java program that you can read. Machine writes it in a very different way. It's nothing but mathematics, pure mathematics and nothing else. Those mathematical equations are called models. You must have heard this word, models. Neural networks. You must have heard about deep neural networks. You must have heard about recurrent neural networks and blah, 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 blah. Bahut bhari terms. Stream learning machines and LSTM and BLSTM. It's nothing but it's a mathematical equation and nothing else. It's just a mathematical equation. And probably we are going to discuss one such thing today, which is called a random forest. Okay, which is very famous and very easy. As the name suggests, it looks very difficult, random as forest, but it's actually very simple. So the whole idea that I'm going to talk about today is how to do classification of diabetic data using random forest. Now, what is data in machine learning? Data is any interpretation of the physical world. Now, supposedly, I want to describe Ankita, so I need some descriptions so that I can pinpoint to Ankita in this room. So the first parameter that I will use is her gender. She's a female. Now, this restricts my search space to a very small region where, because there are only few girls in this room. So this is the way you interpret a data. You give some attributes about the data so that it can pinpoint to a particular kind of data. So the diabetic data that we are going to use today will also be mentioning some properties about the people who are suffering from diabetes. And these properties are actually in terms of machine learning called features. Features are nothing but some attributes which are unique. Like if I want to talk about boys in this room, I can classify them into two parts very easily, those who have beard and those who are clean shaven. And then I have two groups. And from the two groups, I can further classify them, those with spectacles and those without spectacles. Now I'll have a different group. You're getting, so these are attributes through which you can pinpoint to a particular boy, and instead of telling everything about him, you just talk about the major attributes. So that's how we represent data. Data is interpretation of the physical world. How do you interpret the physical world? Like if I want to talk about somebody having diabetes, what should I say? I should talk about his glucose level. Yep. Is he on insulin or not? If he is not diabetic, why will he take insulin? If his sugar level is below 100, why should he be diabetic? So that's how you interpret. You don't bring a patient and he comes and says, I am diabetic. That doesn't happen. You have records. Like if you go to a doctor, he sees your prescription and the test reports. And then he talks to you, depending upon what is there available. The test report has got some parameters about you, your hemoglobin count, your CBC, your other parameters, biomass index, and things like that. So this is how we define data in machine learning. It's an interpretation of the physical world. How do you interpret the physical world? Now, given the data, there are two things that you can do on top of it. One is called classification, the other is called regression. Classification means I have some attributes with me and I want to know whether it belongs to a particular class or not. Like if I have attributes, can I say this is an attribute of a male or a female? Okay, this is classification problem. Regressions are slightly different. In regressions, we try to see in classification, the output is always yes, no kind. It belongs or it does not belong. In regression, the output is a real number. So like predicting the price of a house, depending upon the locality and the size and the carpet area and the kind of other attributes, you can predict the price. And this price is not a yes or no, it's a value. So regression problems are used in such situations where you're predicting something like a price of a commodity or like the price of a stock tomorrow, what price it will sell or what price it will close and things like that. But in classification, the answer is always yes, no. It can be two class, so there will be yes for one class and no for other class, or it can be multi-class where it will be yes for one class and no for all other classes. Okay, so this is the difference between a classification and a regression problem. So given the diabetic data, today we are going to do its classification using random forests. Okay, before going into random forest, I would like to discuss binary tree classification. Now, supposedly, I have circles and crosses. Supposedly, I have circles and crosses. And the circles are underlined, okay, while the crosses are not. Okay? The circles are underlined while the cross. Are you able to see this board from there as well? Okay, good. So the circles are underlined while the crosses are not. Okay. Now I want to classify these circles from the crosses. Okay. So I can ask a question. Is it underlined? So if I ask a question, is it underlined? There can be two answers. A yes or a no. And if it is a yes, the circles will come here and the x's will go here. Okay, am I right?
Yeah.
If it is underlined, it is the circles will go here and the x's will come here. This scheme is called a binary tree. At each node, I'm going to ask a question which has got only a binary answer, yes or no, no other answer. And depending upon the yes and no, the data gets segregated. And the question we ask is such that it gives maximum separation among the data. Now, supposedly, this was very simple. I have some circles which are not underlined and some x's which are still underlined. So what I'm going to get over here is an x like this and a o like this. So it's not going to classify very well. Okay? It's not going to classify very well. So now, see, this was feature. What I just talked about was a feature. Underline is a feature. Because based on this feature, this attribute, that it is underlined or not, the data gets segregated. Okay? So if I add more attributes, then probably it's going to get segregated. So now let me give a complement to all O's. Underline the theta. Now I get complements to all O's, and now I ask a question in each node. See, this was the top node. I segregated it into two nodes. These are called leaves. Now I ask the next question over here. Is it complemented? The other attribute. Is it complemented? Again, two answers. Yes or no. So the no will have X with an underline, but this yes will now have O's that are underlined as well as complemented. Here also, I'm going to ask the same question, is it complemented? And I'm going to have a yes and a no. The yes will have this O, which is complemented, and the no will have excess. So by having more attributes, you can pinpoint to the problem much easier. So choosing the right set of attributes is very important, and the paper that was being shown to me, it uses PCA, the principal component analysis, which actually does the same thing. It highlights some of the attributes in the data which have got higher variance and diminishes those which have got lower variance. And if you are aware of statistical learning, then having a higher variance means having more information. Okay? Having higher variance means having more information. It's a higher, more, because if x is equal to 2, what is the variance of this quantity? There's no variance at all. So it's very deterministic. But if x is a probability distribution which looks something like this, centered at 2, now I've got a variance, I've got more information. Because it can take a value of 1.9, it can take a value of 2.1. Of course, it's going to take a value of 2 with maximum probability. But 1.9 or 2.1 is also a very highly likely candidate. So having variance means a lot more information. For this, I give a example like this, which is wonderful. Can you fill the blank? What can it be? क्या होगा? A होगा. Sure. O भी हो सकता है. U भी हो सकता है. 3 वॉवेल ही में से कोई एक चीज होगी. 5 वॉवेल में से कोई एक वॉवेल होगा यहां पर. कॉन्सोनेंट नहीं हो सकता है. But if I give you this, अब क्या हो सकता है? Which has got higher variance? Lower one has got higher variance because it's more undeterministic. I can put BAT, I can put CAT, I can put MAP. You see, it gives a variance. So this is the example to show you that it's less random, this is more random, and this has got more information, that has got less information, because it's easier to predict over there. It is difficult to predict over here. It's more deterministic in nature, this is more random in nature. Okay, I digress a bit. So you need to find attributes in the data which will take you to the right set which you want to detect. Now, this is an example of a binary tree classification. Now, supposedly, if an X also had a complement, then again the confusion would arise, and I will descend down further in the tree using some attribute. Okay? And finally, I'll be able to do it. You do it every day in your life, binary tree classification. You ask a question and you do it. You just did it in that thing. The example I gave, C-T. You asked the question, is it a vowel or not? And if it was a vowel, you just plugged it over there and said, is it a logical sentence, logical word or not? Because cot is logical, cut is logical, cat is logical, CIT I don't know. Okay, CET I don't know. So you are doing this binary classification mentally over there. So this is binary tree classification. This works like this. Okay. Now, what attributes to choose and what not to choose, and how to ask questions at the node. This is a very important concept which is required. And for this, we use the concept of entropy. Have you heard this word entropy? Yes. Good. So it will be easier for me. Supposedly, I have got 10 balls. Okay, 5 are red and 5 are blue. And they are in the same bag. Okay, they are in the same bag. What entropy is? Entropy is a measure of distortion. It's a measure of distortion or impurity in the data. Since I am mixing blue and red balls, it's very difficult to know where exactly the blue balls are and where exactly the red balls are if they are scattered all around. So I can measure the entropy, and the entropy is given by negative of summation I is equal to 1 to n, rather let me put the capital N, pi log of pi, thank you, where n is the number of classes. So in my problem over here, n is 2. Okay? Now, what is the probability of P red? There are 5 balls which are red, and there are 5 balls which are blue. Then what is the probability of red balls? 1 by 2. And what is the probability of blue balls? 1 by 2. So can you plug it over here and tell me what will be the entropy? Let me call this as E. What will be the entropy in this case?
It would be 0.30.
It will be 1.
Oh, yes, yes.
It will be 1. Simple. Okay, maybe you are confused. This should be log 2, log to the base 2. So if I do it, this will be summation, rather, why to use summation? 1 by 2 log to the base 2 plus 1 by 2 log to the base 2, and log to the base 2 is 1. So half plus half is, so it's 1. Okay. So in such a beautiful data where all examples are equal, you'll always get an entropy as 1. Okay, because I took 5 red and 5 blue, each class having equal number of representation, so of course your entropy is going to be 1. Okay, fine. Now, let me call this entropy as parent entropy. This is my parent entropy, which is equal to 1. Fine? क्या हुआ भाई? बोर लग रहा है? नींद आने लगी? ठीक है? Now supposedly at this top node where my bucket is with 5 red and 5 blue balls, I do a splitting. Using some criteria. I do a splitting and I get 4 balls here, all of which are red. Okay? And I get 5 blue and 1 red over here. Okay? I get 5 blue and 1 red over here. Now, can I compute the entropy at each of these nodes? See, I descended from the top node, which had a E parent equal to 1. Now, I've come to this node and I want to find the probability of this. Okay? Now, since at this node, all balls are blue, there is no entropy at all. Is there anything? No, there's nothing. It's all 0. So the entropy at this node E1 will be equal to 0. What will be the entropy at this node? No, we have to calculate it. It will be 5 by 6 log to the base to 6 by 5 plus 1 by 6 log to the base to 6. Am I right? See, how did I define the probability over here? Pi log pi. Okay? So what is the probability of blue ball among 6 balls? 5 by 6 and log 1 by pi. Okay. Log whatever it is, I am forgetting it. जो भी है, is log 1 by pi or 1 by pi? Sorry then. Okay, so it's log 1 by pi. So this quantity, let me call this as E2. Did I do the mathematics right? Do you get it? What is the probability of 5 blue balls among 6 balls? 5 by 6. And what is the probability of 1 red ball among 6 balls? 1 by 6. So I'm going to do this calculation. I'm going to call this as E2. Now the net entropy at this node is the weighted average of E1 plus E2, where the weight of E1 is 40%. There were 10 balls, 4 got classified over here, so this is 40% weightage, this is 60% weightage. So the total child entropy, let me call this as E, will be equal to 0.4 times E1 plus 0.6 times E2. Okay? Got it? And now, if I subtract E parent minus E, this quantity is called information gain. This quantity is called information gain. Okay? So this was 1, E parent was 1. This will come out to be something, and this will give me some information gain. Now the splitting is done using the criteria which gives you maximum information gain. What I mean by that is, supposedly, you understood information gain? Supposedly, I have got some data with 3 features A, B, C. The data has got 3 features A, B, and C. Let me say that he is a male, he is 6 feet tall or taller, 6 and more, and he is bearded. Using this, I want to classify somebody among this room. Let's see who comes into this list. Okay. So if it has got 3 features like this, which feature to use to split the data? So what I'm going to do is, I'm going to split the data using the criteria A. I'm going to split the data using criteria B. I'm going to split the data using criteria C. Okay? Each time I'll get an information gain. I just showed you. Let me call this as IGA, IGB, IGC. I'll get an information gain or not. I just explained it to you how I'll do it, information gain. The one that gives me maximum among this will be used as a criteria for the first split in the binary tree. Let me say that this is the max. So the first split will be according to this. Now I have got data with properties A and C, and I've got data with property A and C classified on the basis of criteria B, because it gave me the maximum information gain. And again, at this point, I'm again going to split it with respect to A and C. Okay? And compute the information gain. Are you getting it? The maths. Because if you don't get it, there's no point going ahead. Okay? So again, I'm going to repeat this process, but not with respect to B anymore, because B has already been used. Okay? Right? So I'm going to classify it on the basis of A and C which gives me the information gain more. Let's say it is A. So now I have got data with respect to C. And I'm done. Okay. Now supposedly I have a problem that I want to trace a a Telugu girl among these diaspora. Okay. So what are the features that I can take? Gender, female, South Indian, diaspora, language, Telugu. So the first question I can ask is male or female? I'll get a yes, no, all the female one side, all the male one side. I'm not considering males anymore because I'm trying to track a Telugu girl. All the Telugu girls I want to classify. Next question I'm going to ask, South Indian or North Indian? Again a yes, no. All the North Indian, that means the Hindi or Assamese or Rajasthani or Gujarati speaking people will be in one group, and Tamil, Telugu, Malayalam, Kannada speaking people in the other group. Now I'm going to ask the question, Telugu or not? Okay? This is one way of splitting. I can start with Telugu itself in the top. Is Telugu? Now I get a split. All male females speaking Telugu in one side, all male females speaking, all non-Telugu in one side. Now I'll ask another question, male or female? All the Telugu female will go to one side and Telugu males will go to one side. Which one is a more effective tree? Huh? No. Second one. Because there was only 2 split and I'm done. First tree, you see, how did I descend? Male, female, first descent. Then South Indian, North Indian, second descent. And then the deeper you go into the tree, the chances of making an overfit is higher. What is overfit? Overfit is a scenario where you learn the data so beautifully that if your new data comes in, you have hardly got any idea how to work with it. Supposedly, I learn it on all Telugu speaking people, but I forget one of the dialects of Telugu and my test data comes from that dialect of Telugu. I'm pakka going to make a wrong guess because I fitted it on a data which is a different version of Telugu. Okay? So going deeper in a binary tree means you can overfit. Overfit situation means the training data classification accuracy will be very high, but the test data accuracy will be very low. That's overfit. Underfit is the just bigger problem, where it learns its accuracy on the training data as well as the test data, both is very poor. So having a good data is a very important thing. You should have a diverse data with a lot of variation so that neither underfitting happens nor overfitting happens. So see, male, female, first split, South Indian, North Indian, second split, Telugu, non-Telugu, third split. I went 3 layers down in the binary tree. First case, Telugu or non-Telugu. First split, male or female. Second split. You see information gain coming over there? Which one had a more information gain? Telugu or non-Telugu? So of course, going by this feature, Telugu is a better split. Okay. So this is how a binary tree works. Are we clear with binary tree? Do we have an image for binary tree?
Simulation cell.
Okay, leave it. Leave it. I drew this. Okay, fine. Now, supposedly I want to buy a pair of jeans, and I am not very good at shopping. So, what do you usually do? Or mobile. Jeans बहुत simple है. You want to buy a 5G mobile, and you are not good at mobiles. What do you do? Ask a friend. Just one friend? Multiple friends. कोई Xiaomi को बढ़िया बताएगा, कोई सैमसंग को बढ़िया बताएगा, कोई ओप्पो को बढ़िया बताएगा, कोई किसी कैमरा के फीचर्स पे ड्वेल करेगा, कोई उसके स्नैपड्रैगन पे ड्वेल करेगा, कोई मीडियाटेक पे ड्वेल करेगा, कोई रैम की कैपेसिटी पे ड्वेल करेगा, कोई 5 मेगापिक्सल है कि 15 मेगापिक्सल है इस पे ड्वेल करेगा. फाइनली तुम क्या करते हो? यू टेक द आउटपुट ऑफ अ कमिटी ऑफ पीपल, है कि नहीं? 5 फ्रेंड मिल करके अगर ये कह रहे हैं कि ओप्पो F9 लेना अच्छा है, you asked 5 friends, and among this 3 said Oppo F9 is very good. I don't know whether Oppo F9 is a brand or not. Just give an example. Oppo बढ़िया है. You go and buy Oppo. Do you do that? Of course you do that because you trust these 5 people, and you have asked them, and 3 went in favor of Oppo, so you bought an Oppo. अब अगर Oppo खराब निकला तो फिर तुम समझ लो क्या करना है दोस्तों के साथ. ठीक है? Can I have some water, please? ठीक है? So, do you get where I'm hitting? I have one tree, I get one output. Is it good enough? What if I have more trees and I have more outputs? And I take a final voting among these trees. Won't it be a better idea in a classification problem? Because if my one tree goes wrong, I'm expecting the other 3 or 4 trees going right. So if 5 friends have asked, one suggested Samsung, one suggested Xiaomi, 3 suggested Oppo. So because there is no tie, so I'll go for an Oppo, and I'm expecting that 3 people saying it means Oppo is good. So similarly, if I don't have one single binary tree, if I have a cluster of binary trees, where these trees are going to give outputs, and I'm going to take a final polling among the outputs, and I'm going to choose the decision of the majority or the committee. So if 10 trees are there and I choose the output that goes in favor by 7 of them and against by 3 of them, I'm going to go with a yes. Or if 7 go against it, or if 6 go against it, I'm going to go against. This is nothing but a random forest. Now, why 5 people? Why don't you ask the same person 5 times?
Interesting.
भाई एक आदमी को 4 बार पूछोगे तो क्या उसका व्यू पॉइंट बदल जाएगा? So what are you looking for? You are looking for a variation in opinions. Since 5 people are using different gadgets, okay, so they are uncorrelated. The one who is using Samsung is going to be biased towards Samsung. Thank you. भैया ठंडा पानी दे दीजिए, हमको सर्दी नहीं है. ठीक है? The one using Samsung, यार बोलते ही शुरू हो गया. Nazar lag gayi. Huh? So the one using Samsung is going to be biased towards Samsung. The one using Xiaomi is going to be biased towards Xiaomi. The three using Oppo are not really going to be biased towards the same property of Oppo. Some will like its touch, some will like its RAM, the other may like its camera. So what do I need? I need people who have got varied opinions such that their opinions are uncorrelated. That means the opinion of one is not influenced by the opinion of the other. If I get 5 people like this, then my voting is going to be more unbiased. That's my point. So a random forest is a collection of uncorrelated binary trees. That's the definition. A random forest is a collection of uncorrelated binary trees. Each one of them gives an independent output, and finally we select the majority which goes in favor or against. Okay, so if I have 10 uncorrelated trees, then I am going to go with the opinion, let's say 7 go in favor and classify it, then I'm going to classify it as ओके मुझे लगा मेरे लिए था ऐसे डॉज देके जा रहे हो यार ठीक है इतनी इज्जत देने की जरूरत नहीं थी हम बोतल से पी लेते हैं एनीवेज सो you want trees to be uncorrelated. Now the problem is that you have one set of data. How do you learn uncorrelated trees on the same data? You can learn only one tree. है कि नहीं? Or I just showed you if I had a data and I asked the question, let me show you, I had the same data. The first question I asked was male, female. Then I asked North Indian, South Indian, and then I asked Telugu, non-Telugu. Same data, I asked 3 questions. Okay, thank you. क्योंकि अगली बार वो गाने में फिर इतना ही टाइम लगाएंगे. See, I had a data which was a bunch of male, female. I asked this question, I got this tree. I asked another question, Telugu, non-Telugu, female, male. You see, using the same data, I learned 2 trees. You get the trick? Using the same data, I learned 2 trees. And these 2 trees, if this make a mistake, not necessarily this will also make a mistake. There's no guarantee. Of course, they can both make a mistake, but these 3 are uncorrelated because this has been learned using a different set of questions, and this has been learned using a different set of questions. Am I right? So using the same data, you can learn different trees such that they become uncorrelated. What I mean by uncorrelated is that the opinion of this tree should not affect the opinion of this tree. Okay? So there are 2 rules to do that. One is called bagging. The first is called bagging. Supposedly, I have got a data set 1, 2, 3, 4, 5, 6. It has got 6 points. Okay, it has got 6 samples. It has got 6 samples. I am going to create multiple splits of this data, which will each have 6 samples, but selected from this in a way that there are repetitions. Excuse me. That there are repetitions allowed. That means one of the set S1 can be 1, 1, 2, 2, 3, 3. The other set can be S2, which will be 1, 2, 3, 3, 4, 5. See, each of them has got 6 samples, but they are different because I'm allowing repetition. I'm allowing the same example to be repeated. And the other I can create as S3 is equal to 2, 3, 4, 4, 5, 6. Again, 6 samples, but different. So by this, you can use the same data, but use it in a very different way. So a tree learned on this data will be different than a tree learned on this data than a tree learned on this data. Okay, so using the same sample, you can same set of examples, you can create different trees by using the technique called bagging. This is also called bootstrapping. Okay, it's also called bootstrapping, but there is a slight more to bootstrapping. Bagging is more relevant over here. Okay, the other thing is random feature selection. Now, supposedly, I have got, see, this was the example of random feature selection. I selected a different feature in the beginning to start this tree. The feature was the gender. While here, I selected a different feature, which was the mother tongue. Okay, so what I do, I restrict the tree from seeing the data. So, supposedly, I have got a data which has got 3 features. A, B, and C. What I'm going to do is, I'm going to show only features A and B to the first tree, and B and C to the second tree, and A and C to the third tree. I'm not going to show it all the features, so I'm forcing it not to learn from all data by bagging, and not to learn from all features by random feature selection. Did you get this point? So the first tree will learn using only A and B. The second tree will learn using only B and C. And the third tree will learn using only A and C. And they have got different sets as well. This is going to S1, this is going to S2, this is going to S3. So none of the trees sees the entire database 1, 2, 3, 4, 5, 6. And none of the trees sees the entire feature set as well. So as a consequence of this, this tree, and this tree are going to be uncorrelated. So now if this gives an output as class 1, this gives an output as class 2, and this gives an output of class 2. So since the majority is going in favor with class C1, okay, I'm going to choose class C1 as my output. Are you clear with the theory? Do you want to take a short break of 2 minutes and exhale and inhale? It has been too much of mathematics, I guess. So just relax. You want to ask any question, because now we are going to go into codes. This was the theory. कितना टाइम लिया मैंने इसके लिए? 1 घंटा ले लिया. Any questions? कुछ नहीं समझ में आया? हाँ? ऐसा कुछ था नहीं. Of course, बहुत आसान है ये सब यार. यार मे भी मैं बहुत अच्छा पढ़ाता हूँ. ठीक है. मैं एक बार टॉक दे रहा था, मैंने यही कहा बहुत आसान है, तो किसी ने ऑडियंस में से यही बात कही थी, इतना आसान नहीं है जितना आसान आप बोल रहे हैं. ठीक है. Of course, this is not that easy अगर तुम अपने से पढ़ोगे तो, but by taking such examples it becomes easier. And since we have been working on all this for decades now, 12-14 साल हो गए ये सब करते करते, इसलिए ये फिंगर टिप्स पे आ गई हैं ये चीजें. तुम लोग भी करते रहोगे तो लगने लगेगा यार ये बहुत आसान है. चलो, let's take a 2 minutes break. Introduce me to yourself. मैंने तो अपने आप को इंट्रोड्यूस कर दिया. आप लोग बारी बारी से अपना नाम बताएं और अपना एफिलिएशन बताएं. बैठ पे ही.
Sir, my name is Rishabh Ansaria. Sir, I am currently doing my MTech from here, Bhagalpur, in artificial intelligence and data.
Okay, great.
Gopal Kumar, pursuing MTech from Bhagalpur Engineering, Microelectronics and VLSI.
माइक्रो इलेक्ट्रॉनिक्स वाले यहाँ क्या कर रहे हो भाई? तुम लोग VLSI में भी मशीन लर्निंग लगा दोगे क्या? I'm hard hearing a little.
Sorry. I am Rajesh Singh. I'm doing a PhD from
PhD
yeah,
किसके साथ?
Dilip sir के साथ.
अच्छा.
Sir, my name is Mohammed Ashfaq Hassan. I am pursuing MTech from Bihar.
Hello, sir. Nilokul Pathak. I am assistant professor in Bihar Group of Institutes in Greater Noida and research scholar here in Triple.
इतना ही ऊंचा बोलिए, मैं ऊंचा सुनता हूँ. पटना का ट्रैफिक किसी को भी बहला कर देगा.
My name is Robin. I study here. MTech and artificial intelligence and data.
Good.
My name is Ravi Kant. I pursue MTech here. Regarding Bhagalpur.
Good.
I'm Dipali Sharma. I'm doing currently MTech Triple Bhagalpur.
Good.
So my name is Neha Sinha, assistant professor in Bhagalpur College of Engineering, and also doing PhD from this institute.
It's good to see faculties coming to FDPs. It's called faculty development program, but usually faculties don't turn up. It's good. Learning should never cease. Yeah. Okay.
Ankur Kumar Rai, pursuing PhD in Bihar Agriculture University.
Okay. यहाँ agriculture university है.
Yes.
Great.
Sir, myself Gopal Rai. I am pursuing PhD from Soil Science and in Soil Science and Agriculture Chemistry Department from Bihar Agriculture University, Sabor Bhagalpur.
Good.
I am Jafarima, PhD scholar student in Department of Genetics and Breeding, Bihar Agriculture University.
और जो सब जेनेटिक वाले इधर क्लासिफाइड है, सॉरी एग्रीकल्चर वाले इधर क्लासिफाइड है, नॉन एग्रीकल्चर वाले इधर है. So this is the line dividing the two classes. See, this is the problem we are trying to address. इतना सिंपल है. If I draw this line, I know agriculture university is this side, class C1, non agriculture university is class C2 this side. और इसमें भी अगर क्लासिफाई करना है तो थोड़ा सा आगे रहिएगा, तो सब जो है क्या कहते हैं ट्रिपल आईटी भागलपुर वाले, पीछे वाला जो क्राउड है वो इधर उधर का है. See, कितना सिंपली हम लोग डिवाइड करके बना सकते हैं क्लासिफायर. इफ योर डेटा इज सो ब्यूटीफुल. अगर आप मर्ज होकर के बैठ जाते, जो कि आपने नहीं किया क्योंकि ये नेचुरल इंस्टिंक्ट है आपका. हम भी जब यूरोप में थे तो सब इंडियन एक साथ हो जाते थे. यहाँ हम लोग जो है फिर बिहार और उड़ीसा झारखंड अलग हो जाते हैं, वहां सब एक साथ हो जाते थे. तो क्योंकि आप एग्रीकल्चर में शायद ही एक दूसरे का मुंह देखना चाहते हो, बट यहाँ आकर के सब एक तरफ क्लासिफाई हो जाइएगा, क्योंकि वो नेचुरल इंस्टिंक्ट है. वाटरफॉल पॉइंट्स इट्स ओन लेवल. या
So I am Avnish Singh, pursuing my PhD from Bihar Agriculture University in genetics and plant breeding.
ओके.
Sir, Harsh Misra, PhD scholar in Department of Food Science, Bihar Agriculture.
अंकिता PhD scholar NIT Patna with me. यार ये देखो आउटलायर है. ये आउटलायर है. ये गलत क्लास कर रहा है. तुम्हें इधर बैठना तो देखो तो कितना आसानी से मशीन लर्निंग के सारे कांसेप्ट सामने आते हैं. हाँ, ये भी एक्सेस में हमें और फीचर्स चाहिए. अब हम नए फीचर्स लगाएंगे. वो ये है कि हम लाइन ऐसे ड्रॉ कर देंगे. ना इस लाइन के पीछे सब एग्रीकल्चर वाले यही तो कर रहे थे ना अपनी देश से, है कि नहीं? या
Myself Kirti Kumari, I am pursuing PhD in the discipline Soil Science and Agriculture Chemistry from BU Sabor.
Neha Kumari, PhD scholar from the Department of Soil Science and Agriculture Chemistry, BU Sabor.
I am Shalini Kumari, currently I am pursuing my masters from Bihar Agriculture University Sabor Bhagalpur.
My name is Sharukta Yasmin, pursuing my PhD degree from Bihar Agriculture University.
good. It's good to see so many people doing PhD from in agriculture. It's nice. मुझे लगता है सिर्फ मशीन लर्निंग में PhD हो रही है. तो आप लोग मशीन लर्निंग या
Sir, actually, I want to ask that what is underfit condition? Because overfit is that going deeper in binary tree is overfit, but what is underfit?
remaining very shallow.
Okay.
Can you classify a data by just dividing into male and female?
Yeah.
Can you find it? Is it a Telugu girl or not? So the topper I will be there. It's an underfitting because I don't have enough data to learn anything. Yeah, it's good. I'm happy to see. Anyways, I am Shahnawazuddin. I did my PhD long back ago. PhD is a very interesting thing. एक बार मैं IIT गुवाहाटी में सीरीज ऑफ लेक्चर्स दे रहा था और मेरी लेक्चर से लोग बहुत डर गए। तो जो कोऑर्डिनेटर थे वो मेरे पास आए और उन्होंने कहा सैयद लोग बहुत डर गए, उन्हें लग रहा है PhD बहुत टफ होती है, तुम उनसे अगले दिन बात करो। तो मैं गया और मैंने कहा मुझे पता चला है कि आप लोग मेरी बातें सुनकर डर गए हैं कि PhD बहुत टफ होती है। एक्चुअली ये रॉन्ग है, PhD एक्सट्रीमली टफ होती है। ठीक है, इसीलिए PhD की इतनी कदर है। आसान काम तो कोई भी कर लेगा, ठीक है। PhD क्यों इतनी आपका वैल्यू बढ़ाता है? क्योंकि आप जो नहीं एग्जिस्ट करता है उसको ढूंढ के निकालेंगे। PhD की ब्यूटी ये है कि इसका कोई सिलेबस नहीं होता है, इसका कोई एग्जामिनेशन नहीं होता है, इसमें कोई इवैल्यूएशन नहीं होता है। आप खुद सिलेबस डिफाइन करते हैं, आप खुद अपने आप को इवैल्यूएट करते हैं, आप खुद ही अपना एग्जाम लेते हैं और खुद ही को फेल भी कर देते हैं। आपके अलावा कोई नहीं बता सकता है कि आपने कुछ सीखा कि नहीं सीखा, तो इसलिए आपकी वैल्यू बहुत बढ़ जाती है। एंड मेरे हिसाब से पढ़ाई PhD के बाद शुरू होती है, यहां तक तो आप पढ़ना सीखते हैं। Anyway, so that was a good enough break. Let's start our coding.
Sir, I have a question.
Yeah.
So would there be scenarios where overfitting might be beneficial?
Yep. There are scenarios where overfitting is extremely beneficial in a closed set scenario. जैसे कि तुम्हारे क्लासरूम का अटेंडेंस सिस्टम अगर तुम्हारे क्लासरूम के बच्चों के लिए ओवरफिट हो जाए तो इससे बढ़िया क्या हो सकता है? तुम्हारे क्लास के बच्चे को कभी रिजेक्ट नहीं करेगा, बाहर वाले को कभी एक्सेप्ट नहीं करेगा, प्रॉक्सी लगने नहीं देगा। Access denied. Oh, sorry.
There is another.
Okay, sorry.
Another that.
Yeah. Fine. So I'm going to do this all in something called Python. I'm still trying to figure out कि Python को Python क्यों कहते हैं? It's a language. ये तो वैसे ही ना कि मेरे घर में खाना बने और उसको monkey कहें। Huh? Okay, we need the database, please. Bring me my pen drive. Okay, so we do it in Python. And the toolkit I am using is Google Colab. So you can go to Google Colab, start a new project, and then you can write the codes and the comments by just selecting like this. See, if you keep it over here, it will ask you whether it's a code or it's a okay, yeah. See, code or text. If you write something in text, it's like the top thing, importing dependencies. That will not be executed. If you write something in the code, it will be written like this in the Python script format. Python बहुत आसान है। अगर आपने कभी MATLAB पे काम कर रखा है, तो Python से आसान कुछ नहीं हो सकता। बट अगर आपने MATLAB पे काम नहीं किया है, तो थैंकफुली Python और ज्यादा आसान है। क्योंकि आप MATLAB के केस में हमेशा सोचने लगेंगे कि MATLAB में इस काम को कैसे करते हैं। सिंस आपको MATLAB नहीं आता है, इसलिए आप फ्रेशली Python से कर सकते हैं। Python के किसी भी कोड को एग्जीक्यूट करने से पहले you need to import certain libraries. Python has a repository of libraries which assist you to do so many things. You do not write, जैसे कि I want to do A plus B in Python. ठीक है? So the code should know what A is, what B is, and what plus is. Okay? So you need to designate these as variables and this as an operation. Okay? And once you type A plus B, the script should fetch some libraries which do addition of two numbers. Are you going to write addition code every time? So that's how it is. You import certain libraries which do some operations for which the programs are already written in a standard format. Okay? But my point? So the first thing we do is import numpy as np. सारे occupied है क्या? ये वाला यूज कर दो। Use numpy as np. NumPy is a Python script which does operations on numbers. That's all. NumPy. Numbers, Py. Python. Okay. Import pandas as PDs. Panda जो है वो manipulation वगैरह करने के लिए string manipulation जैसे sorting, ठीक है, ascending order, descending order, इस तरह की चीजें अगर आप करना चाहते हैं तो the libraries are in pandas. sklearn will help you to build models. That's where the modeling is done. Okay. So interestingly, most of the models which I just explained one to you, this was nothing but a model which is called a random forest. इसका program already लिखा हुआ है. All you need is to give the right data and call that code in a right way, and it will be done. And that's what I'm going to teach you right now. Okay. So this is what we do first thing. And once you have written this, you run it. It will run and then give a green tick. Once that green tick is there, that means these libraries have been imported. Are we having a net issue over here? इतना slow क्यों है? Okay, it's done. So now your code has these libraries imported. It's something like you want to go to the market to do shopping. So you need a shopper these days. Of course, you cannot go without a poly bag or a bag. Otherwise, 5 रुपए extra लग जाता है bag का. You need your wallet. बिना पैसा लिए नहीं, मोबाइल से भी चल जाता है आजकल, गूगल पे, जीपे वगैरह से आप कर लेते हैं. But you need certain things. You should be equipped with those to do it. And now we are equipped with NumPy, which will do the numeric operations, pandas, which will do the reshaping of the data and standardization, and sklearn that will do the modeling part and the prediction part. Okay. Once that is done, I'm going to load my data. Okay. So to load this data, I'm going to select the data which is there in my external drive. Okay, now I will run this. See, this is the data which I have, and it is a diabetes data which has got 8 properties and 1 outcome. That means there are 8 properties and there is a class label whether the person is diabetic or not. So let's see how the data looks. Let me read this CSV file. CSV file means comma separated variables, nothing else. Don't worry about it. This is how it is written, comma separated. Okay. So this looks very messy. So let's look at it in a human format. Okay, this is the human format. You can read it. Okay, so this is a number, sample number 0, sample number 1, sample number 2, sample number 3, sample number 4. So the 5 samples have been shown, and my attributes, the features are the number of pregnancies. Somebody has got 6, one has got 1, one has got 8, one has got 1, one has got 0. It matters a lot for a diabetic person, how many pregnancies you had. So it's a very crucial data. What is your glucose level? 148, 85, 183, 89, 137. Okay. What is your blood pressure? Okay. 72, 66, 64, 66, 40. What is the skin thickness? These are the skin thickness values. What is the insulin count? This is the insulin count. What is your biomass index? Body mass index, sorry. Body mass index. And then this is diabetic pedigree function. This is a test which you do. Iski value bhi di hui hai, and what is your age? And finally it mentions whether you are diabetic or not. This is how my data is. So 8 features, and finally the 9th column is the class level. Kya hai bhaiya? हमें भी तो खिलाओ, बोला था भुना भुना फाक रहे हो।
सर
हाँ जी।
ये डिफरेंट फीचर्स हैं,
हाँ,
तो रैंडम फॉरेस्ट में ये फीचर हमें असाइन करना होता है या ऑटोमेटिक वो लेगा? जैसे में प्रेगनेंसी हो गई, ग्लूकोज लेवल हो गया, इसको कैसे अरेंज करना होगा, वो उसमें कैसे फिट करना होगा?
कर रहे हैं, बताते हैं। देखो, मशीन लर्निंग में हमेशा एक ट्रेनिंग पार्ट होता है जहां आप लेबल्ड डेटा इनपुट देते हैं। आप सिर्फ डेटा नहीं देते हैं, आप साथ में ये भी बताते हैं कि ये किस क्लास का डेटा है, तो मशीन वहां पे लर्न कर लेता है। तो हम रैंडम फॉरेस्ट की ट्रीज को इस डेटा की मदद से लर्न करेंगे, बिकॉज वी नो द आउटकम, वी कैन ऑलवेज फिक्स द एरर। अगर मेरी ट्री गलत क्लासिफाई कर रही है तो आई कैन ट्वीक द पैरामीटर्स ऑफ द ट्री एंड मेक इट बेटर। Once I have that tree ready with me, now I can feed an unseen data and see whether it gets classified or not. And that's what we are going to do right now. We are going to feed this data to the random tree, random forest, so that a tree is learned. Okay? Once the tree or the cluster of trees are learned, we are going to test it on a database. Okay? So this is how it looks. Now I want to get the total count or the values of. So it says that there are 768 examples, each having 9 columns. And I just told you 8 columns are the features or the parameters or the attributes based on which we are going to do the classification. And the 9th column is the label or the outcome which will be used for learning. क्योंकि तुम्हें भी देखो, जब तुम छोटे थे and you were learning things like, तुम्हें मैंने एक बॉल दी और मैंने तुम्हें कहा दिस इज बी फॉर बॉल। अगले दिन फिर बॉल दी, कहा दिस इज बी फॉर बॉल। फिर बॉल दी, फिर कहा दिस इज बी फॉर बॉल। एंड दिस इज हाउ यू लर्न, क्योंकि मैं तुम्हें बार बार बता रहा हूं बी फॉर बॉल होता है। मैं तीसरे दिन तुम्हें अगर फुटबॉल दूंगा तो तुम क्या बोलोगे? बी फॉर बॉल ही बोलोगे, तुमको फुटबॉल तो पता नहीं है। या बहुत स्मार्ट हो गए तो बोलोगे बिग बॉल। फुटबॉल तो नहीं बोल सकते हो, बिकॉज यू हैव गॉट नो आइडिया। So to learn, you need outcomes. Otherwise, you cannot. Of course, training has to be somehow supervised. There are other ways of unsupervised learning, and there is reinforcement learning. जैसे कि उसका एग्जांपल जो यासिर अबू मुस्तफा का मशीन लर्निंग का कोर्स देखोगे तो you have a bowl of milk which is very hot. You touch it, your fingers get burnt. You don't touch it ever again. This is reinforcement learning. You learn by mistakes. You don't know it is hot or not. You touch it, you are done. अगली बार से, this is how it is going to go. You are going to go close, get the feel of the temperature before touching it. This is reinforcement learning. This is a whole area of research in itself. But usually machine learning tools are supervised. I am giving a label. So this is how I have got 768 data examples, each having 9 columns. As I explained, there are 8 feature values and 1 outcome value. Okay, now let's get the statistical measure of this data. See, this is not that important. Okay, this is not that important, but it helps. Why it helps? Because it helps you to see where are the, what do you call it, major statistics of the data, like the mean, variance, skewedness, or the kurtosis. These things help you a lot. See, if I know that the distribution of data is centered about 2 and has a variance of 1, if anything x has a value of 10, is there any chance it belongs to this group? So having some idea of mean and variance helps you to pick outliers. Okay? So that's why we do this. So this gives you count. First thing is count. How many example has each feature? So all of them have 768 examples corresponding to each feature. What is the mean pregnancy numbers in the entire database? What is the mean glucose level in the entire database? What is the mean blood pressure in the entire database? That is given by the third row or the second row, whatever it is. What is the standard deviation? Okay. What is the minimum value? 0. No pregnancies, no glucose, no blood pressure. Okay. What is the mean value in 25%? This is quartile, centile, decile kind of things. So these help you to understand the min value, the max value. Like somebody is having a glucose level of 199, too high. 100 के ऊपर जाना ही खराब बात है. 199 is too high. That means the liver is not working at all. Okay, liver या pancreas? I guess pancreas. Sure, the liver. क्या फर्क पड़ता है? हम लोग मशीन लर्निंग वाले, हमें तो फाइनली पिक करना है कि उसको ब्लड प्रेशर, शुगर है, डायबिटीज है कि नहीं है, पैंक्रियास से हुआ हो या किसी और चीज से हुआ. हाँ, मशीन लर्निंग वालों को इससे कोई मतलब नहीं होता है कि हुआ कैसे. डेटा है, चर्न करो, पता करो. So this is what we are doing. Next, what we are going to do is we are going to strip this data into two parts, where I am going to check how many examples belong to non-diabetic class and how many examples belong to the diabetic class. I am giving 1 as the value to the diabetic class and 0 as the value to the non-diabetic class. Fine. Now I am going to group it by outcomes and see the mean values. For non-diabetic class, what is the mean value? Now see, this is how it is coming. If the mean value is something around about 3.2, the chances of that person being diabetic is less. You're getting a feel of the distribution. If the glucose blood sugar is around 109 and you can knock, let's say 90 se 120, then the chances of that person being diabetic is less because the outcome is 0. But if it is 140 plus, that means 130 to 160, chances of person being, that's what I just showed you. If you have this distribution and the value comes around about 10, this does not belong to this class at all. So I should have another class which should have a mean value centered about 9. Then there it can lie. So that's what it is coming out to be. You see, the blood pressure 6870, this is very close. 1922, 6800. So this is how you are getting a kind of distribution of the data in each of the classes, the mean value. This is just the mean value. You have higher order statistics like variance, kurtosis, skewedness. जितना हायर ऑर्डर जाओ, तुम लोगों ने मोमेंट जनरेटिंग फंक्शन वगैरह पढ़ा होगा, जितना हायर ऑर्डर स्टैटिस्टिक्स जाओगे, इट्स डिफिकल्ट टू कंप्यूट देम, बट इट हैज गॉट मोर इंफॉर्मेशन बिकॉज़ इट इज व्हाट यू कॉल, तुम लोगों ने वो ज्यादा ब्यूटीफुल कर्व मिलता है उससे. बट अभी हम लोग कुछ ऐसा करेंगे जिसकी वजह से ये और इजीली मीन और वेरिएंस से ही हो जाएगा काम. ओके, नाउ नेक्स्ट थिंग वी डू इज वी आर सेपरेटिंग द डेटा into class and into features and labels, where X represents the 8 columns among the 9 and Y represents the outcome 1 and 0. Okay, क्योंकि हम ऐसे ही फीड करेंगे डेटा को मॉडल को. ओके, सो इसको प्रिंट करके देखो क्या होता है. So now it's showing only the 8 feature values, not the outcome. ओके, क्योंकि हम आउटकम को वेरिएबल y में कर दिया है. So all 768 examples and their 8 features, they are in a X. So X is a matrix. 768 rows and 8 columns. Okay, while Y is a vector, which is a single column matrix actually, which has got the class labels. For each of the examples, it has got a class label. Okay. The next thing is data standardization. That's what I was referring to right now. What I'm going to do is I'm going to Gaussianize this data. I'm going to make its distribution look Gaussian. Why Gaussian? Because Gaussians are beautiful. क्यों? क्योंकि Gaussian का डेरिवेटिव Gaussian होता है, Gaussian का इंटीग्रल Gaussian होता है, And Gaussian can be parameterized using only two values, the mean and the variance. If I know mean and the variance, I know the Gaussian. If the mean is mu and the variance is sigma square, then the Gaussian is 1 by 2 pi sigma square ka root e to the power of minus 1 by 2 sigma square x minus mu, the whole square. So by just knowing mu and sigma, I know the Gaussian. Gaussianization का एक बहुत बड़ा फायदा ये होता है कि Gaussianization helps in removing additive noises and at times convolution noises also. What you are going to do is you are going to make the mean of the data zero. अगर हम डेटा का मीन जीरो करें तो जितने भी एबरेशंस होंगे वो कैंसिल आउट होने लगेंगे. You getting my point? जैसे कि एक बहुत सिंपल एग्जांपल देते हैं. तुम लोगों ने टैप डिले लाइन फिल्टर पढ़ा है कि नहीं, आई डोंट नो. सपोजेटली मेरा डेटा है, उसमें ऐसे करके एक बल्ब है, ठीक है. मैं इस डेटा को ऐसे करके सब्ट्रैक्ट कर दूं तो क्या होगा? हाँ, अगर ये चीज नॉइज थी तो रिजल्टिंग डेटा में क्या मिलेगा? That is mean normalization. You make the mean zero. मैं इसके mean को, because this is what giving me a different mean. मैं इसका mean zero कर रहा हूँ और इसका variance unit कर रहा हूँ. So that is data standardization. You make it Gaussian in nature with zero mean and unit variance because now the behavior of the data is very easy to show. So Gaussianization एक बहुत important process है जो PhD first year में applied mathematics वाले पढ़ते हैं. So that's what I'm going to do using the next few commands. See, now this data is very different from what we gave as an input. This has got 8 columns, but now the values are such a way that each column is a Gaussian distribution with zero mean and unit variance. That's what we did. Okay. Now X is the standardized data and Y is the outcome again. Print X, print Y. You see this is X. Y तो नहीं change करेगा क्योंकि हम उसको outcomes को तो जो है Gaussian नहीं कर देंगे ना. Outcomes वही रहने देंगे. ये Gaussianized हो गया है. Each column has, now this, see तुम उसको भी दे सकते थे, ऐसा कुछ नहीं है. But pre-processing helps a lot. मेरे supervisor साहब कहते थे, if you have perfect features, you do not need a classifier. Because the feature itself is good enough. जैसे कि मुझे मेरे बेटे को recognize करने के लिए कोई classifier की जरूरत नहीं है. Do I need a machine learning tool to recognize my kids? Not at all, because I know the perfect features about my kids. If you have a perfect classifier, any feature is good enough. So अगर हर आदमी का दिमाग इतना बढ़िया फीचर होता कि हर के बच्चे को पहचान लेता, तो किसी के भी बच्चे के बाप का नाम बताने की जरूरत थी नहीं, माँ का नाम बताने की जरूरत थी नहीं, है कि नहीं? सब एक दूसरे को पहचान लेते आराम से, जैसे पीके में होता था, और कुछ बोलने की जरूरत नहीं है कि नहीं? वो तो माइंड टॉक कर लेता था उनका. You're getting my point. You do not need features if you have got a perfect classifier, but we have neither of the two. So since binary tree is going to make an error, so I'm doing some standardization of the data so that some noise is removed by mean and variance normalization or Gaussianization. Okay. So then finally, I'm going to split this data into a train and test set. I have got 768 examples. I'm going to put 20% of it into testing and 80% into training, because this is where I want to learn and test. Okay. So this train test split will do this. And now if you see, it will give me a count. Total data examples were 768, each having 8 feature values. out of which 614 has been used for training, having 8 feature values, and 154 has been used for testing, having 8 values, 8 feature values. That's what I did by splitting. And every time you split it, it's going to give you random split. It's not going to be the same. And this is very important. Finally, I am going to learn a random forest classifier. Okay, and it is available in the library sklearn.ensemble. So inside sklearn, there is an ensemble library which has random forest classifier. So once I run this, it is going to learn a random forest classifier with 10 trees using the entropy as the criteria. Okay, and this helps in bootstrapping. Random state helps in bootstrapping. Finally, I want to check what is the training accuracy on the, okay, this was modeled specification and this is where the training happens. 10 estimators means there will be 10 trees in the cluster of random forest. Finally, let me check what is the classification accuracy on the training data. Oh, it's huge, 98%. See? So 98% of the time, if I tested the training data back on the model, I'm getting correct. So still it is failing for 2. See? Had it been an overfit, 100% will start. It will never fail on the training data. Okay? Let's check its accuracy on the testing data. And let's print its value. It's just 70.1%. Got it? This is how we are working on this. So each line in itself is doing a lot of things, which I just explained on the board. Everything I explained on the board, these are simple Python commands which are doing this, which you can simply borrow from us and run in your computers. Okay? Finally, let me give it one single value, which I have decided on my own. The pregnancy, number of pregnancy count is 5, blood sugar is 166, blood pressure is 19, and all other parameters, I don't remember what they are, body mass index and skin thickness and other things. I am giving this data as an input, one single value, randomly done by me. I am going to check whether this person is diabetic or not. Can you tell me he should be diabetic or not? डायबिटिक होना चाहिए. प्रेगनेंसी 3 से ज्यादा है, ग्लूकोज 140 से ज्यादा है, तो ये प्रेग्नेंट होना चाहिए ना. सो लेट्स डू इट. ये इनिशियली वो उसको उस फॉर्मेट में ला रहा है जिसमें फीड करना है और कुछ नहीं है कोड का. फाइनली यहाँ पे प्रिडिक्शन हो रहा है. The person is diabetic. So see, since you had seen that distribution, that the mean number of pregnancies is 3.4 and the mean count of blood pressure, blood sugar was 111. तो तुम्हें पता चल गया था कि अगर ब्लड प्रेशर इतना भाग जाए और ब्लड शुगर इतना भाग जाए और प्रेगनेंसी इतनी भाग जाए तो पर्सन इज गोइंग टू बी डायबिटिक. And that's why you were able to classify this data pretty well, because 166 is very high blood sugar. Okay? So I guess that's all for today. Tomorrow we'll talk about support vector machines. Did I finish too early?
We have a half an hour time.
Okay, that we can do for some question answers.
सर
हाँ,
इसमें जो डेटा हम लोग प्रिंट करते हैं और जो फिगर वगैरह जो भी है तो उसको हम लोग एक्सट्रैक्ट डायरेक्ट कर सकते हैं क्या, जैसे वर्ड फाइल में मतलब कहीं भी एक्सट्रैक्ट
डेटा रीड कमांड से हो जाता है ये, बट मालूम है वैसे मत करो तो अच्छा रहता है. इस तरह के जो टूल किट्स होते हैं ना, जैसे कि स्पाइडर है या कोलैब है, ये ज्यादा अच्छा काम करते हैं, क्योंकि पाइथन में इंडेंटेशन की बहुत बड़ी इश्यू होती है. तो एक टैब एक्स्ट्रा दे दोगे ना, पूरा कोड खराब हो जाता है.
नहीं, मेरा ये सर, जैसे मान लीजिए हम ये मैंने कोई डेटा डाला CSV फाइल में और हमने उसको यहाँ पे रन किया और उसका जो भी आउटपुट आया उसको मुझे अपने थीसिस प्रेजेंटेशन में कहीं पुट करना है,
हम्म।
मैं उसको कर सकता हूँ कि नहीं यहाँ से?
स्नैपशॉट ले लो ना इसका, प्रिंट स्क्रीन।
और कोई ऑप्शन नहीं?
नहीं नहीं, है बहुत सारे ऑप्शन है। अंकिता कैसे रीड करते हैं इसको?
अगर इनको डेटा रीड करना तो हम एक्सेल शीट में दिखा सकते हैं।
नहीं, उसको ये चीज रीड करनी है।
तो इसको एक वेरिएबल में स्टोर करके किसी एक एक्सेल
हाँ एग्जैक्टली, इसको एक वेरिएबल में स्टोर कर दो इस चीज को, और उस वेरिएबल को इंपोर्ट कर दो।
जैसे उसको मैंने यहाँ से कॉपी किया
हम्म,
और ले जाके वहाँ
कर सकते हो।
सर
इसको छेड़ करके देखें हम लोग। बोलो कोई नंबर।
सर जैसे एक कमांड है, जैसे हम लोग आर सॉफ्टवेयर में यूज करते हैं, तो उसमें
ये आर क्या होता है यार? हम पाइथन से ही डरे हुए हैं, तुम आर पे लेके जा रहे हो।
सर इसमें
यार तुम लोगों ने गंद मचा दी है। पहले सी लेके आए, फिर सी प्लस प्लस किया, फिर सी हैश किया, फिर आर में चले गए। कुछ दिनों बाद लेटर्स की कमी हो जाएगी।
सर लाए तो आप ही लोग ना, हम लोग तो बस उसको फॉलो कर रहे हैं।
हम तो इलेक्ट्रॉनिक्स इंजीनियर, हम कुछ नहीं लेके आए हैं।
सर आया तो आप लोग ही क्यों ना?
कंप्यूटर साइंस वाले हैं, ये पाप उनका है। ये दोष कंप्यूटर साइंस वालों का है।
तो सर ब्रांच तो आपका ही ना।
ना 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 ना, इलेक्ट्रॉनिक्स हम इस पाप से परे हैं। हम इलेक्ट्रॉनिक्स वाले हैं।
सर मैं कुछ करता
हाँ।
हूँ, एक कमांड है जो भी कमांड यहाँ पे यूज कर रहे हैं, ऐसा मतलब जिसे हम लोग इंपोर्ट करते हैं उसमें टूल्स में जाइएगा, तो जो हम करना चाह रहे हैं, जैसे हम प्रिंट करना चाह रहे हैं, वहाँ पे प्रिंट के लिए जो कमांड दिया जाता है हम कॉपी कर लेते हैं। ऐसा यहाँ पे
यहाँ पे भी कर सकते हैं,
कैसे?
ये पता नहीं, बट कर सकते हैं, कोई बड़ी बात नहीं है। सर्च कर लेना गूगल पे यार, मैंने आज तक कोलैब यूज नहीं किया है। ओके, सो एक नंबर बोलो जो हम लोग ब्लड शुगर का डालें यहाँ पे। इतना हाई क्यों कर रहे हैं? थोड़ा लो करके देखते हैं। और ब्लड प्रेशर को भी नीचे कर दें क्या? फिर से प्रिडिक्ट करके देखें। क्या हो गया? इंटरनेट पे चला गया क्या? अच्छा, गूगल कोलैब के साथ एक प्रॉब्लम है, एक बार ये स्लीप हो जाएगा या शटडाउन हो जाएगा तो ये सब कुछ फिर से करना पड़ता है। ठीक है, तो देयर इज अ वे। जो एक्सपर्ट लोग होते हैं वो एक स्क्रिप्ट में कोड को लिख देते हैं इन द पाइथन फॉर्मेट एंड देन दे रन इट फ्रॉम द टर्मिनल। ठीक है, बट वो थोड़ा डिस्क्रिप्टिव नहीं लगता, इसलिए हम लोग कोलैब में लेकर के आए। ये थोड़ा फैंसी फैंसी सा लगता है, वो बहुत बहुत बोरिंग लगता है, बट ज्यादा साइंटिफिक लगता है। जुपिटर पे भी कर सकते हो। क्या हो गया ये अंकिता?
डेटाबेस से शुरू कर लो,
फिर से करना पड़ेगा।
इनिशियलाइज हो रहा है।
ये सब तो किया हुआ है।
एक बार आ गया ना, पर्सन इज नॉट डायबिटिक,
नॉट डायबिटिक हो गया वो, देखो हमने वैल्यूज ट्वीट कर दी एंड इज नो मोर डायबिटिक। ठीक है, तो इस तरीके से मेडिकल सर्टिफिकेट तो हम लोग जमा करते ही हैं, वैल्यूज ट्वीट करके। बीमार पड़ जाते हैं बिना मतलब का। हाँ, सो लेट्स हैव सम क्वेश्चन आंसर। मैं थोड़ी देर के लिए बैठ सकता हूँ? ओके, थैंक यू। आप लोग कुछ सवाल पूछना चाहते हैं तो पूछिए, कुछ नहीं समझ में आया हो, क्योंकि टुमारो आई एम गोइंग टू गो इनटू अ मोर मैथमेटिकल मॉडल व्हिच इज सपोर्ट वेक्टर मशीन। रिकॉर्डिंग बंद कर देना।
सर अगर आपको इंटरेक्शन कर रहे तो करेंगे।
अब कोई कुछ नहीं कर रहा है, ठीक कर देना तो बंदी है। क्योंकि बिना मतलब मेरी रिकॉर्डिंग हो रही है, पानी पीते हुए, खाना खाते हुए, सारी दुनिया को पता चल जाएगा हम पानी भी पीते हैं।